In this video, we will discuss another example for converting NFA into DFA using subset construction method. This is the given NFA and we have to convert it into DFA. So let us first construct transition table for that. So list out all the states Q0, Q1, Q2 in one column and all the input alphabets 0, 1 in row. And on intersection, write down the appropriate transition. So on reading Q0, on reading 0 from Q0, we are moving to state Q2 and there is no transition on 1 from Q0, so that will be 5 and so on. We have to fill up all the rows. Next, we have to start with the initial state Q0 and we have to find out delta transition for input 0 and input 1. So when we compute the delta Q00, the output is Q2. So Q2 is the newly generated state. So we have to generate successor of Q2 in future. And when we read 1 from the Q0, it's 5. So we have one state which is not yet processed, that is Q2. So this is the partial transition diagram we can say. From Q0 on reading 0, we are moving to state Q2 and on reading 1, we are going to null or the 5 state. In step 2, we will compute this generator of Q2. So we will compute the transition on 0 and 1 from the Q2. So delta Q20 would be Q0 Q1 as we can see from the diagram or the transition table. So Q0 Q2 is the new state which is yet not processed. And delta Q2 1 is Q0. Q0 is already explored in step 1. So let us add this in our partial solution. So it looks like this. In next step 3, we have to generate the successor of unprocessed states, that is set Q0, Q1. So now we have 2 states and we have to find out transition on 0. So that is equivalent to taking union of delta Q00 and delta Q10. So that leads to Q2 and transition on 1 from state Q0, Q1 gives us Q0, Q2. So Q2 is already processed in step 2, but Q0, Q2 is a new set of state. So by adding this to our transition diagram will look like this. In next step, we have to generate successor of unprocessed states, that is Q0, Q2. And when we read 0 from Q0, Q2 states, that is equivalent to union of delta Q0, 0 and delta Q2, 0. Which is nothing but Q0, Q1, Q2. So this set is not yet processed. So we have to explore it in future. And transition on 1 from Q0, Q2 is equivalent to Q0. Q0 is already explored in step 1. So we don't have to process it. Let us add equivalent arcs into this. So it looks like this, that when we read 0 from Q0, Q2, it is moving to set of states Q0, Q1, Q2. And on reading 1, we are moving back to state Q0. Now still Q0, Q1, Q2 is not processed or its successors are not generated. So that we have to do in next state. So when we compute the successor or the delta function of Q0, Q1, Q2 on input 0, that can be given by the union of Qi, 0. That is delta Q0, 0. Union delta Q1, 0, union delta Q2, 0. And when we find the appropriate transitions and take the union, it will give us Q0, Q1, Q2, which is the set state itself. And transition on 1 from Q0, Q1, Q2 will lead us to Q0, Q2. So Q0, Q2 is also already processed. It is in transition diagram as we can see. So we do not have any new states. Only some arcs will be added into the transition diagram. And those arcs like this. When we read 1, we are moving to Q0, Q2. And when we read 0, we are remaining same state. So there is a self loop. So this is final DFA. We can replace or rename all the set of states. We can replace Q0 by A, Q2 by B, Q0, Q1 by C, Q0, Q2 by D, etc. Right? But ultimately what we are doing is we are combining the set of states into single state. so that it becomes now DFA. And this is the transition table for the DFA. We can always rename the set of states and we can make it represent it as a single state. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.